Okay, so we will solve all these questions in the review list for the exam 2. Okay, exam 2. So first question is simplify radical 50. Right, radical 50. So here we need to split 50. The order doesn't matter. You can use 5, 10, 10, 5, 2, 25. And then 10 is 2, 5. So eventually we got 1 number 2, 2 number 5. And then here simplify means we move out pairs, right? We move out pairs. So this is 5 outside the radical, and then 2, because there's no pairs, still stay inside radical. Okay, inside radical. So that's number 1, right? For positive number. So now if the number is negative, so we simplify radical negative 18. Negative 18. Now we need this definition. Square root of negative n is square root of n times I if n is positive, right? N is positive. Okay, so the square root of negative 18, so this will be square root of 18i, right? 18i. So what is this letter I? I squared is negative 1, or I is square root of negative 1, right? So I will take care of the negative sign. Okay, negative sign. Okay, so now for square root of 18, we do factoring again, right? 2, 9, and then 3, 3. So we got square root of 2, 3, 3i. So now pair of 3 come out. We got 3 radical 2i. Okay, 3 radical 2i. So the difference between positive and negative square root is there is the letter I, right? There is the letter I. So that's number 2. And then number 3 is rational power, right? Rational power. So a to the negative m over n's power. So here m means root, m means power, and the negative sign means flip, right? Flip. Okay? Yeah. So number 3, 27 to the negative 2/3 power, right? 2/3 power. So now this 3 means root. So it's cube root, right? 2 means power, so it's second power. And then we have to flip. Flip. So you can flip it in the beginning or you can flip it in the end. Okay, in the end. So I will use the integers, so I will flip in the end, right? So this is the cube root, right? This number 3 gives us cube root. And then we got negative 2's power. So this is 3 to the negative 2's power. And now we look at second power, right? What's 3 squared? 9. So 9 to the first negative 1's power. Now we got flip it, 1 over 9. Okay, 1 over 9. So step 1 is the root, right? And then step 2 we do the second power. And then the last step here I do the flip step for negative sign. Okay, for negative 1's power. Okay, for negative 1's power. Okay, yeah. So you can do it the other way, right? Some students did flip in the beginning. So this is 2/3, so you got 1 over 27 to the positive 2/3 if you flip in the beginning, right? And then 1, any power of 1 is 1, so now this is 2/3 power of 27, and then you change it to root powers, you will get the same answer. Okay, same answer, 1 over 9. So that's number 3. Okay, that's number 3, question 3. So question 4 is similar. So question 4 is simplify this 8x cubed over y squared divided by xy, right? Divided by xy. And this is to the 2/3 power. So now this is positive powers, so no flipping, right? No flipping. Okay, so now we look at these 3 parts separately, right? First is the number 8 to the 2/3 power. And then we have letter x to the 2/3 power. And then we have letter y to the 2/3 power. Okay, yeah. So now for number 8, we use the root and powers definition for rational power again. So this is cube root of 8, and then second power, right? So this is 2 squared, and this is 4. So now for x, we will use subtraction here. So the division means third power minus first power. Now this is x squared to the 2/3 power. So now this is multiplication, right? So this is 2 times 2/3. Okay, 2 times 2/3. So this will be 4x 4 over 3's power. Okay, 4 over 3 power. 2 times 2 is 4, right? 2 times 2 is 4. And for letter y is the same, right? Y is 2 minus 1's power. That's for this division. And then we got y to the first power, and then to 2/3 power of power formula, 1 times 2/3. Okay, if there is a letter goes to power twice, so we use multiplication, right? Multiplication. And then we got y to the 2/3 power. 1 times 2/3 is 2/3, right? 1 times 2/3 is 2/3. So that's the answer for problem 4, the rational power part. Okay, so now number 5 is the multiplication division for radicals. Okay, so the topic is simplify, right? Simplify. So again, simplify means we try to find pairs and then move it out, right? Move it out. So step 1 is important, is the new step, right? We put everybody in the same big radical, okay? And then this is 6, so it's 2, 3. 8 is 2 to 2, divided by 3. So now 3 cancelled, so we have square root of 2, 2, 2, 2. So this is 2 pairs. 1, 2 come out, another 2 come out, so we have 2 and 2 outside, nothing stay inside, so the answer is 4. Okay, the answer is 4. So here for multiplication division, essentially we just factor, cancel common factor, move out pairs. Okay, so now for addition subtraction, same thing, right? Same thing. We need to factor to get like radicals, right? Like radicals. Okay, so now let's factor everybody under the radical sign. So what's 45? 5, 9, and then this is 3, 3. Right? We got 5, 3, 3, right? That's 45. Okay, and then 20. 20 is 4, 5, and then 4 is 2, 2, right? So we got minus 6 radical 2, 2, 5. Plus 5, 10. 10 is 2, 5, right? 10 is 2, 5. Okay, yeah. So we factor first, right? We factor first. So now we will do the moving out part, right? This is a pair of 3, go out. This is a pair of 2, go out, right? There's no pairs, so nothing come out. So the last term remain as 5 radical 10. Okay, the first term will be blue 3 outside, and then this is from inside to outside. We got a 3 outside again, and then the single number 5 still stay inside. And then 6 outside, and then we got the number 2 from inside, and then 5 still stay inside. So we got 9 radical 5 minus 12 radical 5 plus 5 radical 10. Okay, so now they are like radicals because they have the same radical 5, right? They have the same radical part, radical 5. Okay, so now combine like radicals, addition subtraction means 9 minus 12 radical 5 plus 5 radical 10. So this term has no like radicals, so you just leave it, right? Leave it. So we got negative 3 radical 5 plus 5 radical 10. Okay, so now we don't have like radicals anymore. That's the final answer. You cannot simplify more, right? You cannot simplify more. Okay, yeah. So what's number 7? Number 7 is the distribution, right? Is the distribution. So this is radical 6 minus radical 2 times radical 6 minus radical 2, right? We distribute radical 6, distribute negative radical 2, right? Here we have to look at this as a negative number, okay? Negative number. So now let's write down the 4 products. Radical 6 times radical 6, and radical 6 times negative radical 2, and the negative radical 2 times radical 6, and then the last one is negative radical 2 times negative radical 2. Okay, so they are the FOIL if you know the following method, right? Okay, yeah. So now this is 6, this is what? 2 times 6, 12, but we need 2 to 3, right? We want to see 2 to 3, okay? That's when we multiply. So minus 2 to 3, this is 6, 2 and 6, minus 2, 6 again, so it's 2, 2, 3 again, right? And then this negative, negative cancelled. Radical 2 times radical 2 is 2. Okay, it's 2. So this is 8 minus, this is 2 radical 3, this is another 2 radical 3. This is 8 minus 4 radical 3. Okay, radical 3. So this is just distribution, and then multiply radicals means factor move up pairs. Okay, move up pairs. So this is the basic operation, right? Basic operation. So now number 8 and number 9 is a new topic, right? They called rationalize denominator. Okay, we have two cases, right? Cases. Case 1, denominator has one radical. Denominator is one radical term. Okay, is one radical term. So that's our number 8. So we got radical 2x over radical 5y. How to rationalize the denominator? We use the same radical term. We just repeat the denominator. Right, repeat the denominator. So now what's in the denominator? We got 5 and y, right? Yeah, so now they are both pairs. So we got 5 come out, y come out, right? So in the denominator, there will be no radical sign. They both come out, right? They both come out. So now for numerator, you just leave it, right? It's 2x times 5y. If you like, you can give me a better answer, 10xy. Okay, 10xy. So here we only care about the denominator, right? If denominator is one radical, you just use the denominator times the denominator. Okay, yeah, one radical, use the same radical. Okay, same radical. So now case 2, we have two radicals in the denominator. Denominator are two radicals, two square roots, right? Two square roots. Okay, so now we want to use conjugate radical. So let me write down the conjugate radical formula. So it's a plus radical b times radical a minus radical b. So this will be radical a squared minus radical b squared. So this is a minus b. Okay, a minus b. Okay, yeah. So if given plus, you multiply minus. If given minus, you multiply plus. Then you will get a minus b, which has no radicals. Okay, no radicals. So now the example in the test, this is number 9. So radical 5 minus radical 3 over radical 5 plus radical 3. Right? So what is given? Given plus. So now we will multiply by the conjugate, which is minus. Right? So multiplied by minus. Okay, both top and bottom multiply the same thing. Right? Same thing. Okay, so make sure denominator is the plus sign and the minus sign. Okay, so now by this formula is square minus square. So down the bottom is radical 5 squared minus radical 3 squared, square root and then square cancelled. So it's 5 minus 3 is 2. Right, is 2. So we get a good denominator. So with numerator, you can just copy the numerator. Right? Okay, yeah. So now you can copy it and then leave it. Okay, leave it. So now I will use FOIL and then write down a better solution, right? Distribute the radical 5, distribute radical 3 negative. Then we will get 5 minus 2 radical 15 plus 3. Okay, and then you can combine that 5 and 3. You got 8 minus 2 radical 15. So now divide by 2. We got the answer is 4 minus radical 15. Okay, 4 minus radical 15. Okay, yeah. So the distribution on top is very similar to the question 7 that we solved. Okay, yeah, you just have 4 products and then you put them together. You got this. Okay, you got this. So that is number 9, and then number 10 and the 11, they are radical equations, right? Radical equations. So let me write down the step first, right? So step 1, isolate. Step 2, second power on both sides, right? Second power on both sides. And then what's the next step? Solve for x. And then the last step, check it. Check your solutions, right? Check solutions. Okay, check solutions. So let's look at the easier example number 10. We got radical 3x minus 2 is radical 4x minus 6, right? So now they are already isolated, so step 1 is trivial. Now let's go to step 2, square both sides, right? Square both sides. So after that, we got square root, second power cancel, square root, second power cancel. So we got 3x minus 2 is 4x minus 6. Okay, yeah. So now let's move it. So negative 2 go this way, 4x go that way. So 3x minus 4x is 2 minus 6. So negative x is negative 4, x is 4. Divided by negative 1, right? Divided by negative 1. And then we have to check it, right? We have to check this number 4, right? Number 4. So if x is 4, what's left hand side? So left hand side is radical 3 times 4 minus 2. So this is radical 12 minus 2 is radical 10. That's left hand side. And the right hand side is radical 4 times 4 minus 6. Okay, x is 4, right? So it's 4x minus 4. Now it's 4 times 4 minus 6. So this is radical 16 minus 6, radical 10, right? So left hand side is equal to right hand side. This is a true solution, not a fake solution. Okay, not a fake solution. So now for the harder question, we do the same steps, right? Same steps. Step 1, isolate. Step 2, square. Step 3, solve and then check. Okay, and then check. So let's use this board. Let's solve the harder case. The harder case means the equation you solve for step 3 is harder. Okay, it's a quadratic equation. A quadratic equation. So let's write down this number 11. So this is radical x plus 9 minus 3 is x, right? So isolate. You move 3 to that side. Radical x plus 9 is x plus 3, right? So now you only have this term, only one radical term isolated on the left, right? On the left. So step 1 is done. Step 2, square both sides. Okay, so now second power radical cancelled, x plus 9 on the left. So on the right hand side, we have x plus 3 times x plus 3. Okay, follow your method. With distribution, you will get x squared plus 6x plus 9. Right, plus 9. So now you move these two to that side. We got 0 is x squared plus 5x, right? Minus x minus 9, right? Minus 9. The 9 cancelled, we got 5x. So now you can use quadratic formula or factoring to solve this. So now x is 0. That's the first solution. X plus 5 is 0. We got second solution. So x1 is 0. x2 is negative 5. Okay, negative 5. So if you can factor, this part is easy. You can get good integer solutions. Okay, good integer solutions. So now let's check these two solutions, right? That's the last step, step 4 here, right? Step 4. So if x is 0, what's left hand side, right hand side? So left hand side is, you check it in the original given equation. X plus 9 minus 3, so x is 0, so this is 0 plus 9 minus 3, so this is radical 9 minus 3, so it's 3 minus 3, 0. And right hand side is 0, right? Because right hand side is x, so this is 0. Okay, so left hand side is equal to right hand side. Good. So this is a good solution. Okay? Yeah. So now if x is negative 5, so what's left hand side? Left hand side is negative 5 plus 9 minus 3. So this is radical 4 minus 3 is 2 minus 3, negative 1. And right hand side is x, so it's just negative 5. So left hand side is not equal to right hand side, because left hand side is negative 1, right hand side is negative 5. They are not the same number, right? Now this means that's a fake solution. Okay, you have to drop or delete that solution. Okay, delete that solution. So the last step, checking step, is very important for the radical. Okay, for the radical. Okay, so now we go to the quadratic part, right? Quadratic equations. So we have two main methods to solve it. For easier questions, we can factor. So number 12, So 2x squared minus 2x minus 4 is 0. So you have common factor 2 here. Factor out GCF, then everybody divide by 2. We got x squared minus x minus 2. So now ST method, right? Product is negative 2. Sum is negative 1. So S is negative 2. T is 1. So we got 2x minus 2. X plus 1 is 0. Okay, it's 0. So this is the factoring method, right? Factoring method. So now this is 0. We got x1 is 2. This is 0. We got x2 is negative 1. Okay, negative 1. Okay, so it's for easier quadratic equation. So now for harder quadratic equation, you have to use quadratic formula, right? So like number 3 and 13. So a is 1. A is how many x squared? B is negative 2, C is 4, right? C is 4. So now what's the quadratic formula? X is negative B plus minus square root B squared minus 4AC divided by 2A. So the negative B, so this is negative 2, so this is B, plus minus B squared, so it's negative 2 squared minus 4AC, 4 times 1 times 4, divided by 2A, so 2 times 1. Okay, 2 times 1. You don't have to simplify anymore, leave it, that's the answer, right? That's the answer. So I will simplify a little bit for you. If you can continue, right? This one is 16 minus 4 minus 16, negative 12 in here. And denominator 2, right? Negative 12 is positive 12 radical I divided by 2. So now 12 is 2 to 3 again. So we got 2 plus minus 2 radical 3i divided by 2. So this is 1 plus minus radical 3i, right? Radical 3i. Okay, yeah. So on my paper, I got it wrong. I write down 1 plus minus 2 radical 3i, right? Yeah, but it should be radical 3i. Okay, because divide by 2, 2 cancel, right? 2 cancel. So that's number 13. Okay, so here we did use the idea in the question 2, right? Negative square root of negative number is square root of positive number times I. Okay, times I. Okay, yeah, so number 14, you can solve it using any method. So you just repeat the quadratic formula and then you got the answer. Okay, you got the answer. So A is negative 1, B is 6, C is 5. They use quadratic formula. This is negative 6 plus minus 6 squared minus 4 times negative 1 times 5 divided by 2 times negative 1. Y is not x, right? Yeah. And you don't have to simplify, just leave it. Okay, leave it. Only for the radical equation you have to simplify, right? Because otherwise you cannot check solution. Right? Only for good numbers, good integers, you can check it. Okay, you can check it. Okay, yeah. So this is the radical part. Okay, radical part. So now change degree measure to radian measure, or change radian measure to degree measure. We just multiply it by half circle over half circle, right? So if this is degree to radian, we multiply it by pi over 180. Right, the example is here, number 15. Question 15 is 6 degree change to radian, so it's times pi over 180. This cancelled. We got 60 pi over 180. So now divide by 60 on top and bottom. We got pi over 3. Okay, pi over 3. Or you can think 0, 0 cancelled, divide by 10. And then 6 cancelled, we got 1/3. So it's pi over 3. Okay, pi over 3. So this is multiplied by pi over 180. You want radian, radian on top. You want cancel degree, degree on the bottom. Okay. So now number 16 is the other direction. Okay, you want to change radian to degree. Okay, to degree measure. So now this is pi over 2. We want to change it to degree measure. So now we multiply it by 180 over pi. You want degree, degree on top. So this is 180 over pi. So now we can get pi cancelled. That means radian measure cancelled. So this is 180 degree over 2. If you can simplify a little bit. Give me 90 degree. Okay, 90 degree. Okay, so we just multiplied number 1, but in different measure, right? So half circle over half circle give us number 1. Right? So these two multiplications essentially are number 1. So we get the same value but different measurement. Okay, different measurement. Number 17 is the Pythagorean theorem. Okay, so I already posted 2 old lectures about Pythagorean theorem and angles, triangles. So here I will just solve these questions. Okay, number 17, we got 3 here, 9 here, and x there, right? So now by the Pythagorean theorem, this is the hypotenuse. This is the c side, right? Okay, so they are a and b. The order of a and b doesn't matter, right? A squared plus b squared is c squared, right? So we got 3 squared plus 9 squared is x squared. Okay, so this is 9 plus 81 is x squared. So this is 90 is x square root of x squared. Right, 90 is x squared, and then you take square root. 90 square root is x. Okay, because when you take square root on both sides, so the second power and this radical sign will cancel each other, right? Yeah, so last step, take square root, right? Take square root. So that's the answer. And you can simplify 90 as 3 radical 10 if you can, right? Or you have time, okay? Or you have time. So now number 18 and 19 are the special triangles, right? You have to remember these 2 special triangles. 45, 45, 1, 1 radical 2. So that's 45 degree. And then 30, 60. Opposite of 30, 1. Opposite of 60, radical 3. And then opposite of 90 degree here, right angle, 2. Okay, 2. So now number 18, we want to find sine 45. Okay, so we are looking at this angle, 45 degree, right? 45 degrees. So now this is the opposite side of that angle. This is hypotenuse of the blue angle, and this is the adjacent of the blue angle, right? Sine is opposite over hypotenuse. So sine 45, using this picture, we got 1 over radical 2. Okay, 1 over radical 2. Okay, yeah, so for this question, you have to draw a picture, draw a graph, and then show me the definition and then the ratio. Don't just give me the ratio, okay? Don't just give me the ratio. Okay, yeah. So now, the next question, we got more angles, right? More angles. Okay, yeah. So number 19, we got cosine 45 plus sine 30, and then minus cosecant 45. Okay, cosecant 45. So now let's write down the 6 trig definitions, right? 6 trig definitions. So sine is opposite of the theta divided by hypotenuse. Cosine is adjacent divided by hypotenuse. And tangent is opposite over adjacent. And the flip side, you got cosecant. So this hypotenuse over opposite, that's the flip side, right? And then you flip cosine, you got secant. So this is hypotenuse over adjacent. Okay, and then if you flip tangent, you got cotangent. This one you got adjacent over opposite. Okay, flip means you change numerator to denominator, denominator to numerator. Okay, numerator. So now you have to draw me 2 pictures before you find the ratio, right? Cosine 45, so this angle, opposite, adjacent, and hypotenuse 2, right? Cosine is adjacent over hypotenuse 1 over radical 2. And then sine 30, this angle, so this is opposite, right? So sine is opposite over hypotenuse 1 over 2. Cosecant is here, hypotenuse over opposite for 45, this angle again, right? So it's hypotenuse radical 2 over opposite. Okay, over opposite. So now if you want to combine these three fractions, three ratios, you have to use same denominator 2. How to change them to same denominator 2? So this one rationalized denominator multiplied by radical 2, and this one you use 2 and 2. Right? Then they are all radical. They all have 2 as the denominator. Okay, and then you can put them together. So this is radical 2 plus 1 minus 2 radical 2. So now radical 2 minus 2 radical 2 combine like terms, combine like radicals. You got 1 minus only 1 radical 2 over 2. Okay, yeah. So now for me, the red part is the important part. Okay, yeah. Give me 2 pictures and those 3 ratios. Okay, and those 3 ratios. That's number 19. Okay, that's number 19. So number 20, you are given a right triangle. So this is B. We don't know B. It's angle A, angle B. This is side A. And then this is C, hypotenuse, right? Hypotenuse. Okay, yeah. So we don't know side B. So first you find side B using Pythagorean theorem. A squared plus B squared is C squared. So we got A squared plus B squared is 9 squared. So B squared is 17. B is radical 17, right? This is 64. This is 81. 81 minus 64, 17. Okay, 17. Okay, so now we know this is radical 17. So now they want to find tangent A and sine B. So in the class I said you have to write down the opposite, adjacent and the hypotenuse for A and B separately, right? So what's the opposite of A? Opposite of A, we go inside, we got 8, right? So adjacent of A will be radical 17, hypotenuse is 9. So now for angle B, we go inside, so let's change to green color. So opposite will be B side, right? Radical 17. And then adjacent will be 8, right? Adjacent side is 8. Is the A side is number 8. Okay? Yeah. And hypotenuse does not depend on A or B, right? Hypotenuse opposite of C. Okay, so now you can use the trig definition, right? So what's tangent? Tangent is opposite over adjacent. So this is 8 over radical 17. That's tangent A, right? So now sine B, we use different opposite adjacent because that's for angle B, right? So sine B is opposite over hypotenuse. So this is radical 17 over 9. Okay, over 9. So this is the key part. Okay, different angle, same triangle, give you different opposite side. Okay, yeah. So now for number 21, I already solved it in the classroom, so I don't want to write down the whole question. Okay, yeah, but I will explain and then draw the picture, right? Draw the picture. So you draw this rectangle first, and then you have depression. If the angle is looking down, you use the top triangle, right? That's the for depression. If it's elevation, you use the bottom triangle. If you're looking up, okay, looking up. Okay, so that depends on which way you are looking at, right? Looking up, elevation, green triangle. Looking down, depression, use this blue triangle. Okay, blue triangle. So now this question is, you are on a sailboat and then you are looking up, okay? And then the angle of elevation is 60 degree, right? 60 degree. And then you're looking at the vertical cliff. So this is the top of the cliff, this is the bottom of the cliff. And then is 200, right? 200 feet, 200 foot. That's the distance between the boat and the bottom of the cliff. Okay, bottom of the cliff, foot of the cliff, right? Yeah. Okay, so this is the picture. Okay, this is the picture. So now based on this picture, what they want to find? They want to find the height of the cliff. Okay, how high is from the top to bottom, right? So this is the side they want to find. Okay, yeah, so that's one triangle. This is a two triangle question. So this is number 21, right? So now for the next question, they want to find 60 degrees. So 60 degree, we have a special triangle, 60, 30, right? So this is opposite of 30, 1. This is opposite of 60, radical 3, and this is 2. Okay, this is 2. Okay, so when you label the opposite side, don't look at the picture, which one is longer, which one is shorter. So look at the opposite. Okay, opposite 60, radical 3, opposite 30, 1. Okay, yeah, because sometimes you want to draw the triangle in a different position, wrong position. I chose this angle to be 60 because this angle is 60 here in the larger one. Okay, yeah. Okay, so now we have two different triangles, but now we are looking at the ratio of these two sides for 60 degrees. So that's opposite of 60. This is adjacent of 60. So what's their ratio? Tangent 60, right? Okay, so tangent is opposite over adjacent. So this is x over 200 for the bigger one, and so this is opposite of 60 for the smaller one, adjacent of 60 for the smaller one. So this is same smaller triangle. So let's change the color. Okay, so I use red opposite and then adjacent for the smaller triangle. Okay, yeah, so this is opposite and then adjacent. So this is radical 3 over 1. Okay, so now we have an equation. They are equal, right? They are equal. So x over 200 is radical 3 over 1, sub proportion, cross multiply, right? Cross multiply. So x times 1 is 200 times radical 3. So x is 200 radical 3. That's the answer. That's how high the cliff is. Okay, how high the cliff is. Okay, so the harder part, first you have to draw the right triangle for elevation or depression. You have two choices, right? The second thing is you have to use two triangles, different sides, same angle, to build a proportion, and then you have to solve the proportion. Okay, so this is not an easy question. Okay, so that's the end of this review list.